Hey everyone, Mr. Newman here, and we're going to do some review or more practice problems on trig equations. If you want to do even more practice problems, I can almost guarantee that the questions will come from the textbook from one of those, so feel free to crack open your textbook and try some more of those. Otherwise, let's get started. So one way to solve these equations is to get the trig by itself. In other words, on this one, I'm going to get the cosine of x by itself. One last thing about these equations is that on all of these, we're looking for the answer between 0 and 2 pi. And I will most likely say that on the quiz. If I don't, then you can ask. So between 0 and 2 pi, what solutions are there? So we often need to look for more than one possible solution. And this requires that you really have your unit circle memorized. So if you don't, either take that, go memorize it right now, or find the unit circle somewhere so you can reference it until you have it memorized for the quiz. All right, now solving for x. What I'm going to do is I'm going to do x by itself, so we get cosine of, or I'm going to get cosine of x by itself. That way we can use the inverse trig. So you notice cosine of x equals -1/2. So x equals inverse cosine or arc cosine of -1/2. Well, how do we figure that out again? Remember, you draw a unit circle. Cosine is the x value. Sine is the y value. So if I'm looking for where the x value is -1/2, that's going to be this point right here. That's one of the points where the x value there is -1/2. It's negative because it's on the left side, and it's 1/2 because the two options are for the triangle are 1/2 and √3/2, and we want 1/2 is the shorter side, so I drew the triangle that has the shorter side on the x, in the x direction. There is another solution. Oh, quick, what is that theta? That's 2 pi over 3. There's another solution, though, that's somewhere on the unit circle where x is -1/2, and that's when it's below the x-axis. So right down here, that triangle also has x as -1/2, and that is 4 pi over 3. So the two solutions are 2 pi over 3 and 4 pi over 3. Now remember, it's always a good idea to check your answer, so I'm going to do that for both of these. The way you check it is you want to plug it back into the original equation. So I'm going to start with 2 pi over 3. When you plug that in, we know that that cosine of 2 pi over 3 is -1/2. We just did it. And when you do that, notice 2 times -1/2 is -1, and -1 plus 1 is 0, so that checks out. Let's try the same thing now for 4 pi over 3. We plug that in. We also know that cosine of 4 pi over 3 is -1/2, so the same thing happens. So those two are our solutions between 0 and 2 pi. For the next one, I'm going to get x by itself, and this time I have secant squared of x. I can square root this. Now you have to be careful because when you square root it, you need to say plus or minus. Those are both solutions to this equation. One of the solutions is secant of x equals positive √4 over 3, and the other one is secant of x equals -4 √4 over 3. I'm going to put this in terms of cosine instead because I know that I know my unit circle in terms of cosine and sine. And cosine of x is, you flip it, √3 over 4, also known as the square root of 3 divided by 2. That should look a little more familiar, and we will be able to find that on the unit circle. So let's draw the unit circle. √3 over 2 is the longer side, so I'm going to draw the triangle where the x direction is the longer side. That's these two triangles right here. There's one triangle, and there's the other triangle. Both of those have cosine of the angle, the x value that is, as √3 over 2. And those two angles are pi over 6 and 11 pi over 6. Cosine of x equals -√3 over 2. That's the other one we have to consider. Those two triangles are going to be over here, 5 pi over 6, and over there, which is 7 pi over 6. That means that there are 4 solutions, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Rather than checking all those on the video for the sake of time, I'm just going to check one of them. Pick one at random. I chose 5 pi over 6. And so let's first figure out what is secant of 5 pi over 6, and then we'll square it. Well, we know it's -2 over √3. When we square that, we get +4 over 3, and 3 times 4/3 is 4, so 4 minus 4 is 0, so it checks out. So those, and you can check the rest on your own, those 4 are the solutions to this equation. For the next one, this involves factoring. This is a different strategy. For this one, I'm going to get all of the trig onto one side, and I'm going to factor out a cosecant. Now, because these are both multiplied and they're equal to 0, we know that each one has to be equal to 0. So cosecant of x equals 0, or secant of x minus 2 equals 0. Cosecant of x equals 0 is actually not possible. One reason is because the cosecant of x is 1 over sine, and there's no number we can plug in there to make that equal to 0. But the better reason is if you graph it, and you know cosecant is 1 over sine, so it looks like this. If you graph it, cosecant never reaches all the way down to 0. So cosecant of x can't be 0, so that's a dead end. That's nice. That's fewer solutions that we have to check at the end. On the other hand, secant of x minus 2, we can solve for secant of x. We get secant of x equals 2. And when we do the reciprocal of secant is cosine, and the reciprocal of 2 is 1. That is possible. So x is the inverse cosine of 1/2. Well, when does that happen? I feel like we just did this, and we think we did, or we're going to again. 1/2 is when the triangle is right here, because the x value is 1/2. This time it's positive 1/2, not negative 1/2 like the first problem. So that happens at pi over 3 and 5 pi over 3. So those are our 2 solutions. Let's check one of them real quick. So secant of, I'll just do pi over 3. When we do this, we get 2 times, because secant of pi over 3 is 2, just like the cosine of pi over 3 is 1/2. Cosecant of pi over 3 is going to be 2 over root 3. Whoops. I had it written incorrectly there, but here's the correct writing. The fact that I wrote it incorrectly doesn't affect the answer a whole lot, because I'm not going to actually multiply that out. I just know that that on the left is the same as the right, so check that is the correct answer. You can check again with 5 pi over 3. And when you do that, you notice that we get 2 again for secant of 5 pi over 3. And the cosecant this time is negative 2 over root 3, because it's the reciprocal of sine. But again, that doesn't matter because those 2 are equal, so they are the same. So we checked that both of them are correct, so those are, those are the correct answers, pi over 3 and 5 pi over 3. All right, for the quadratic, we have 2a squared plus a minus 1. This, guys, is the similar quadratic equation. This is the way you want to view this right here, because it's cosine squared and then cosine. So I'm going to factor this first just to see what my cosine x would be. And feel free to write that down on your quiz or on your worksheets as you're practicing this. Write it out in terms of a simpler variable. Just replace all of the cosine of x's with, I don't know, a or whatever you like, whatever letter you like, and then we can factor and see what we get. So when we factor this, we notice we get 2a minus 1 and a plus 1 of the 2 factors. So I'm going to do the same thing, but instead of writing a, I'm going to write cosine of x on the left here. So 2 cosine of x minus 1 and then cosine of x plus 1. Since they're both multiplied and they're equal to 0, we know that each of these must be, either one must be equal to 0. Either 2 times cosine of x minus 1 is 0, or cosine of x plus 1 is 0. Then cosine of x is going to be 1/2, and I feel like we just did this, which we think we did, deja vu. But I'll go ahead and write them down again. Here's one triangle that works because the angle is 1/2, and here's the other triangle that works. So pi over 3 and 5 pi over 3 are the 2 possible solutions there. And when cosine of x equals negative 1, there's only one solution there. That is, the inverse cosine of negative 1 is pi. So those are our 3 solutions. You can check them for the sake of time. I'm not going to check them, but you can check them on your own. And all 3 of those are correct possible answers. So pi over 3, 5 pi over 3, and pi are the 3 solutions. All right, for this last one, this is the one that tripped a lot of people up on previous quizzes. what you need to do is we need to somehow make those all the same function. It'd be really nice if I could change that secant into a tangent instead. So that's what I'm going to do. I'm going to change secant into tangent. Well, you can't just change it directly into tangent because they're not equal. But we have this equation, sine squared plus cosine squared equals 1, that we can alter slightly to make it in terms of secant and tangent instead. I'm going to divide by cosine of squared of x. And a lot of people ask, why are you dividing by cosine squared of x? Well, the reason is twofold. First of all, secant is 1 over cosine squared of x. So secant squared will show up here in this equation. Tangent squared is sine squared over cosine squared. So again, there I also want to divide by cosine squared. And when I do that, we get tangent squared of x. Cosine over cosine is 1, so that's just 1. And then 1 over cosine squared is secant squared. Look, now I can substitute secant squared out and substitute in tangent squared of x plus 1. So I'll do exactly that. Instead of secant squared of x, I put tangent squared of x plus 1. Now I can distribute the two and combine like terms, and you get 3 tangent squared of x minus 1 equals 0. Well, tangent squared of x is 1/3, and I'm getting a little worried because I don't have tangent memorized, but here's what I'm going to do. I'm going to take the square root of both sides. Don't forget the plus or minus. I'm going to write out tangent of x equals plus or minus the square root of 1/3. Let's simplify this a little bit. That's similar to plus or minus 1, that's equal to plus or minus 1 over root 3. And if we rationalize the denominator, we get plus or minus root 3 over 3. All three of these are equal and all are valid. The one on the right is technically the correct answer, quote unquote, if I ask you to simplify it. However, the one in the middle is going to be the one for me that's the easiest to identify on the unit circle. Let me show you what I mean. Let's draw the unit circle out. I know that at 45 degrees, or pi over 4, tangent of theta is 1, because sine of theta and cosine theta are equal. So I'm not even going to worry about that. Let's write down the points on either side of it. So root 3 over 2, comma 1/2, and 1/2, comma root 3 over 2. One of these, when we do sine over cosine, is going to give us 1 over root 3. Well, have you figured it out yet? Yes, it's going to be this one, because 1/2 divided by root 3 over 2 is going to be the same as 1 over root 3 over 2, 1 over root 3. And that is what looks similar to this one right here in the middle. Now, that means tangent of pi over 6 is 1/2 over root 3 over 2, and you notice that's 1 over root 3. Well, that's not the only possible solution. There are more, and the reason for that is because we have a plus or minus. You have to be careful to catch all of those. Those 4 solutions I jotted down are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All of those, when you take the tangent of them, will give you plus or minus root 3 over 3, or plus or minus 1 over root 3. So, I'll let you check those on your own time, because all 4 of those should be correct. Thank you for watching.